Okay, hello, hi again. So this is the second part of lab 2. So I'm just breaking into chunks. Right, the first part is on Numpy. You saw creating matrix and a bit of matrix manipulation. Now, if you want to do linear algebra, which is like very rich, various kind of matrix manipulation, you want to use a Scipy package. Yeah, Scipy. Scipy represents scientific Python. Please go to scipy.org and go through the documentation. They have all those operations that we do in linear algebra. Okay, the first example is, of course, first you call your SciPy into your Python notebook. So scipy.linear, this is linear algebras package, scipy.len alg, yeah, linear algebra, and then I'm giving a short name, LA, as presenting linear algebra. So later on, I'm going to call this and put a dot to access all those functions available in there. Okay, there you go. Now I brought it in already. Shift enter. Okay, now I have an array. Okay, so A is an array, yeah, 2 by 2 array, and then I'm going to get the inverse. So getting inverse, if you see, if you do by hand, it's not easy. So rather doing calculating inverse with Python, especially using linear algebra, is as simple as linear algebra dot the function inverse. Get, and then of course the argument here is your matrix. Shift enter. It's as simple as that to get an inverse of a matrix, right? Of course, now if I do matrix multiplication with the original A multiply with the inverse of A, I will get a matrix identity, yeah? 1, 1, and 0. In fact, this is 0, yeah? 10, this number simply means 10 power of negative 16. That is how a computer stores 0. This is like 10 power of negative 16, very, very small. Okay, so it's a 0. So we get matrix identity. So you know this is the right inverse for matrix A. Okay, so again, if you do by hand, this is how you do it, right? Okay. Now, not all matrices have not all matrices have inverse, right? For example, this matrix has no inverse, right? So if I simply push as a linear algebra package to do it, so for example, LA.inverse matrix A, it will complain. It will say, no, this is a singular matrix. There is no inverse, right? So there is no inverse. How to check the inverse? You can always check the determinant, right? So for example, this is array. You calculate the determinant of this matrix, the matrix that we did just now. The determinant is almost 0. It's 10 power negative 16. So true enough, there is no inverse for this matrix. All right, next, solving a linear equation. So we have linear equation. Of course, this is the equation, two equations. We can represent it in the form of matrix. Yeah, 1, 5, and then negative 2, 7, and then matrix B as 7 minus 5. So solve it. A, see, LA dot solve. Yeah, LA dot solve. A, comma, dot. So you have to inverse it. B dot T. T is transpose, sorry, not inverse. Shift enter. So there you go. This is the solution. You can always get norms as well. Say norm simply means, in another term, we call it the distance. Actually, when it comes to data science, there are so many types of distances that you can use to compute to differentiate between data between point cloud and etc. Okay, so LA dot norm B minus A order 1. This is actually called L1 norm. There's another name for it. It's called Manhattan distance. The usual distance that you are very much accustomed to would be Euclidean distance. Yeah, this is Euclidean distance, the standard Euclidean distance equation. Yeah, theorem Pythagoras, right? Right. Whereas the Manhattan distance has this equation, right? So the absolute value of the summation of all the element-wise subtraction. Okay, so what I'm trying to say is that, for example, so the answer for Manhattan distance is 3 minus 0, 4 minus 0. You add them up, you get 7. So that is the Manhattan distance. So you do element-wise subtraction and make it absolute and then add them together. That is Manhattan distance. Whereas for normal Euclidean distance, you know, this is the equation like. So to do Euclidean distance, the order is none. You put order as none, so you get the Euclidean distance 5. Yeah, 3 square plus 4 square. Yeah, isn't it? Okay, so this is the equation like. Okay, so please have a look. That is Euclidean distance. Of course, there are other ways to compute as well. No worries, we will do it when the time comes. So that would be on Scipy. Of course, there are so many other functions in there. Please have a look. Now let's try to plot a little. Yeah, let's try to plot. We want to always to check with visualization, right? To check our data and etc. So we use Matplotlib, mathematics plotting library. It's called Matplotlib. It is created or developed on top of Numpy. So it's the structure very much close to Numpy. Okay, now let's try. So the first package Numpy. The second page that I'm bringing in is matplotlib.py plot Python plotting library. Okay, as PLT rather than calling it very long actually. So I just give a short name called PLT representing to all those functions which is available in that package. Okay, now let's plot. First is the x values, and then I create the corresponding y values. Y equals to sine x. That's what I'm going to create. So I'm give all the x values first. X is from using a range. If you remember 0 to 3 pi. So np dot pi is the 3 pi with the increment of 0.1. So long list of x. So all the values of x goes into y with sine x, and then plt dot plot x, y, and plt show. So this matplotlib, yeah, if you look at the code, it is exactly the same the way you code in MATLAB actually. Okay, shift enter. So you get to see this is what you get. Okay, let me reduce the size a little. Okay, this is what you get. We assign a wave function. Let's go to the next one. Same thing. So I have x. I have two. One is sine, one is cos. So I have two plots here. So this is the first plot. This is the second plot. And I'm adding a legend, plt.legend. I'm adding the title, and I'm adding the label for y, label for x-axis. So shift enter. So two on top of each other. Two functions plotted on the same graph. So automatically create a legend for you. Yeah. And then the first legend takes the value, the name sine. The second is the cos. So color is automated. You can also customize color as you want if you want. Right. So just play with it. Yeah. And then here we are creating, rather than doing on top of each other, we can also do a subplot. Yeah. I have 2 by 1, 2 rows. Right. 2 rows and 1 column. The first one is this. 2 rows, 1 column. The second row is this. Okay, the same plot actually. So if you shift enter, okay, the first row, you get to see the sine. The second row, you get to see the source cos plot. Okay, so that's how we can create different kind of plots. So a quick plot, yeah, quick plot tutorial. And then you can also do, there's also a package called matplotlib.image. That's now a spy plot. You can also do some sort of manipulation. Why? Because image is basically a collection of matrices. Okay, for example, if you take a black and white image, it is just one matrix where the entries are the intensity of black and white. Black representing is it 0 or 1? Please have a check. It's either 0 or 1, representing one is black, the other one's white. Whereas for gray images, again, just one matrix. The entries are the intensity of the color black, right? Whereas if you take the image of a RGB image, which has the intensity of R representing one matrix, then G, green, representing another matrix, and B representing another matrix. Basically, it's a tensor being laid on top of each other. R is the first layer, and then we have a G, the second layer, and then B, the third layer. Okay, so this is an image in your folder. You can always double click on top of it and check, and then you can check. So once you bring it in mpig, which is the package that we matplotlib.image, and then EIM representing image read, and then this cat.cat.jpg, which is in your folder. So you can check the type. Obviously, it will be in the form of array. You can check the shape, and we can check the D type. D type is simply means the type of element in this matrix. So that this is the matrix, huge matrix, 835 times 1280, and then of course you have three layers. There you go. This is how it looks like. Okay. Okay. Of course, since you have 3 layers, you can play with you can just like manipulate the just like intensity for R, or intensity of G, or intensity of B. So if you want to look at it, just let plot image. Yeah, plot dot image show. But this is the image of the cat. Now, now here simply, okay, I'm creating a new image, so-called blue, and then I'm making one layer 0. So this is how it looks like. I'm like, this is everything, and this, all these layers are going to be 0. Okay, there you go. Okay, you can always save this. Yeah, image save, whatever that you have done, manipulation on top, and you get to see that image in your folder. So another one, same thing, but this time around we're playing with another layer. Okay, and yet another layer. Okay, so this is like slicing. You can always have a look at it. Whatever that matrix manipulation that we did before this, it's like a bonus for you, just like to see you can in fact do some sort of manipulation on your matrix. Yeah. And this is how the layer looks like. Okay, just slicing it. Okay, there you go. Those values, and then this is how the image now looks like. So, and then also you can somehow like choose the type of plot. I mean the type of color that you want to give. For example, here hot CMap is actually the type of color. Right? It's like a palette where you can choose different colors. For example, now using spectral. Okay, this is how it looks like. Okay, so please go through and read and enjoy that. And again, go to the documentation Matplotlib online, and then there are many examples given there. Choose what you want, what you like, and then start playing with it. Okay, so there are actually more doing some sort of a crop, right? Crop, again, what it means is like slicing a part of it, right? Slicing a part of matrix. And then after that, doing some sort of like we call it like we want to like blur it, we want to sharpen it. It's basically again playing with the values of entries. Okay, and then this is like interpolation, like Again, doing some sort of blurring, some sort of that you get to see some sort of blurring or sharpening effect. All right, so that's all for this lab. And then of course do your questions exercise here. So again, this the answer would be very much on top. You just like follow through and then solve it. Thank you.